Welcome to the solution to the Regents physics measurement and vectors problems, problem number 10. Let's start by reading the question here. It says you're going to need your graph paper, so you should have that out, ready to go. It says, during an experiment, a student measured the mass of varying amounts of unknown liquid. The data in the table below was collected, and we have a data table of mass and volume. A asks us to construct a graph of mass versus volume by plotting the values in the table and drawing the curve that best fits all the points. This is definitely something that you've had practice with in the past in other science courses and in math class. So we're going to use this question as a review just to go over a few things here. The first thing we need to decide is, okay, we have mass data, we have volume data. Which one goes on the y and which one goes on the x-axis? I'm going to give you a little clue here and a hint that you really need to remember, and that's when they tell you to construct a graph of mass versus volume, what you have to remember is it is y versus x. The quantity to be plotted on the y-axis always goes in front of the versus, and the quantity to be plotted on the x-axis always goes after the versus. So if you remember y versus x, you will never mess up which piece of data gets plotted on the y and which piece of data gets plotted on the x. Okay? And of course also deals with the difference between independent and dependent variables as discussed in an earlier problem that we did. Alright, so we're going to switch over now, and I'm going to use my computer graphing software. You're going to do this by hand. So you're going to need your graph paper, you're going to need pencil would be the wisest thing to be using here. Trickier with pen because if you make a mistake you can't fix it. And then you also need a straight edge. So make sure all those things are ready, and we'll be back in touch here in a moment. Alrighty, so here we are back, ready to construct our graph. And as indicated, you're going to get a quick little lesson on graphical analysis, the software, graphing software we have in our classroom for your use. And so follow along here and also do a graph by hand at the same time. So we've decided what we're going to plot on the x and what we're going to plot on the y. So let's go ahead and label our data table here. We've decided it's y versus x, so volume goes on the x-axis. Short name is capital V, and the units are in centimeters cubed. And for options, we want to make sure that all our answers are to 1 decimal place. You select that and click OK. What's really neat is it automatically labels your x-axis on your graph when you label it in the data table. We'll double click on the y here. We'll do the same thing. I'll just double checking here. We're starting kind of opposite here, but 1 decimal place for our information out of our data table. And this is going to be mass. Short name is small m in physics, and units in grams. Okay, click OK. And our y-axis is now also pre-labeled and ready to go. Next thing we want to do is we want to choose an appropriate scale. We look at our volume data for our x-axis, and it goes from 0 to 50. So we're going to spread that data out as far as possible. Looks like I'm going to have to wait to change that number. It'll probably change as I type in data. But you want to spread your data out to take up as much of the paper as possible and still keep it on the paper. You know, give yourself a nice linear but healthy scale so that you're using well more than half the graph paper out in width. Same thing for the mass data. Our mass goes from 0 to 39.6, so about 40. So you want to select a good scale that uses most of the paper all the way up through. Well, I can do that on there, so I'm going to change that now. Okay. Well, I'm now able to do that on my x-axis as well. So now I've selected a scale that spreads the data out as much as possible. I'm going to go ahead now and type in the data as given to us in the data table. For you, you can go ahead and start plotting points. My points are going to plot automatically as I type in the data. So at a volume of 0 centimeters cubed, I got, of course, no mass. And continuing on. And at 50 centimeters cubed, I've got a mass of 39.6. All right. So there we go. If you need to pause because you need more time to plot your points on your graph, do that. Otherwise, you can see our points are indicating to us that we've got a pretty good linear relationship here. So our best fit curve to this data is going to be a straight line. So you go ahead and use your straight edge to draw a best fit line with your data. General rule of thumb here is that you want the same number of points above the line as you want below the line. I get the luxury of just clicking on a button here, and it looks like actually the majority of the points are very close to being on the line when you do a best fit here. Okay? Alrighty. So at this point, since our graph is done, and if you need to, pause and finish yours up as you need. We're going to go ahead and head back to the smartboard here to answer the rest of the questions. Okay, so here we are back ready to answer the questions based on the graph that we've constructed. And the first thing we're asked to do in B is describe in words the resulting relationship between mass and volume. Well, our graph has produced a linear fit to the data of mass and volume, and the relationship that results in is, of course, directly proportional. So what that means is that mass is directly proportional to the volume. Okay? So that would be our statement in words. Okay? Now in C, I know it probably is switched around on your problem set, but I'm flipping D and C. We're going to do the slope first. C, find the slope of the graph, including units. And then we have a question to answer after that. What physical name is given to this constant? You'll have actually a much easier task at this than I, because you have more grid pattern, you have more boxes on your graph than I do. But just to review how this is done, a slope, let me scroll down here, we're going to be scrolling back and forth here. A slope, M, is change in y over change in x. And so we need to have a final value for our y and an initial value for our y and x values both. And so we go back up here to the graph, and we're looking for spots on the graph that intersect the grid pattern. We are not allowed to use data points from the data table unless they exactly intersect on our best fit straight line. We're going to pretend that that doesn't happen here, even though that may, just to illustrate the point. And so it looks to me like I have a nice spot here that would make it select a point, and I have a spot there in which I would select a point. Okay? So I'm going to use those two spots to do a change in y and a change in x. Okay, and I mark those two spots with an X right on the best fit line where it intersects the grid pattern. Okay, so final minus initial change is calculated by subtracting taking the final quantity and subtracting the initial quantity. So for our y value, our final y value looks to me to be about 16, and our initial y value looks to be about 8. Yours will be whatever the points are that you select on your best fit line. Now the final x value looks to be about 20. And the initial x value looks to be about 10. 16 minus 8 is 8. 20 minus 10 is 10. So we've got a slope of 0.80. Now we have to include the units. Our y units were grams, and our x units were centimeters cubed. So the units of our slope are grams per centimeter cubed. Okay? Now, what's neat about the using the graphical software is you can see up in this box right here, and I'll circle it, we have some data in there. And it has the equation y equals mx plus b, which you may remember from math class. And of course, the letter in that equation that represents the slope is m, and it's even marked in the box for you. And we can see that the slope is already calculated for us up there, and it says 0.791 grams per centimeter cubed. So we feel pretty good about doing it by hand to get an answer that's 0.80. All right, now to answer the question for C, what physical name is given to this constant? Well, what physical quantity is represented by the units of grams per centimeter cubed? Mass per unit volume. And of course, the answer to that is density. Let me spell that correctly there. And the symbol for that in physics is the Greek letter rho. And it's a kind of a P-looking letter, lowercase r-h-o. The symbol for density in physics is rho. And probably in chemistry and or in earth science, it's been capital D or D. All right, so that answers number 3. And onward to letter D here, it says, use the graph to write an equation relating the volume to the mass of the liquid. Here's how we do this. And this is going to be a very repetitive theme throughout the course. We start with the equation that defines the fit to our data. And that equation, since it's a linear fit, is y equals mx plus b. That's where we start. Now we substitute, for the letters, we substitute what represents them. Our y data that we plotted was mass. So the letter that represents mass is little m. Our slope, we've decided, was our density, and our symbol for that is rho. On the x-axis, we plotted volume, and the symbol for that is v. Plus, our y-intercept is what b represents. We scroll up to our graph, look at where our y-intercept is, and it even tells us in that box right here that the y-intercept is 0.01 whatever. Essentially, if we've done a good job here, it's essentially 0. And so what you get out of this is m equals rho v. And if we isolate that for rho and divide both sides by v, rho equals m divided by v. And what you should recognize from that is that that is the equation to calculate density. That's where the equation came from. It wasn't somebody that just plucked it out of midair and said, I'm going to call density mass per unit volume. The equation for density was created from the graphical relationship between the mass of a substance and its volume. All right, so I hope you've had some good opportunities to learn some things here and to also review. We'll have more practice with graphing, not only in this unit, but all throughout the year.